Chapter 5, Exploring Mixtures and Their Separation. In the previous class, you have learned about mixtures and some methods to separate them. Let's explore more about mixtures, their properties, behaviors, various techniques to separate them. First, classification of mixtures. Here in the diagram, this is given heterogeneous mixtures and homogeneous mixtures. First, homogeneous mixtures. Mixtures of sugar and water, when stirred properly, remains equally sweet in first and the last sip. Such mixtures are called homogeneous mixtures or solutions. Heterogeneous mixtures. A mixture of sand and water is not uniform. Sand particles always settle down at the bottom of the beaker. Such mixtures are called heterogeneous mixtures. Here the example of heterogeneous and homogeneous mixture: sand plus water, heterogeneous mixture; sugar plus water, homogeneous mixture. Activity: add 1 spatula of common salt in a beaker containing 50 ml of water and stir well. Add few drops of milk in beaker containing 50 ml of water and stir well. Add 1 spatula of chalk powder in the third beaker containing 50 ml of water and stir well. Pass flashlight through these beakers and observe. Observation: no scattering of light in salt and water mixture. Subscattering of light in milk and water mixture. Greater scattering of light in chalk and water mixture. Filter each mixture separately. In first two beakers, no residue is obtained in filter paper, but in the third beaker, some chalk powders is obtained on the filter paper. Conclusion: these are different types of mixture. Now this is the tandem effect, flashlight, solution, collider, and suspension. Now solutions. What are the solutions? Solutions are homogeneous mixtures. They are prepared when solute get dissolved in solvent. For example, in a mixture of sugar in water, water is a solvent in which solute sugar gets dissolved. So water is a solvent and solute is a sugar. Then we will get the solution. Concentration of solution. In oral rehydration solution ORS, specific amount of salt and sugar is dissolved in fixed quantity of water. Dilip Mahanapsis and Indian pediatrician first developed and implemented the treatment of dehydration caused by diarrhea and cholera. This revolutionized rehydration therapy and saved millions of lives. If we change quantities of these substances, we will get solution of salt, sugar in water, but not ORS. During spraying of pesticides on crops, we must fix right amount of pesticides in water. The amount of solute dissolved in solvent is called concentration of the solution. How do we express concentration? The three main ways by which concentration can be expressed: mass by mass percentage, percentage M upon M, R upon W. M and W are the same thing. Homogeneous solutions concentrations can be expressed by this method. Mass percentage is mass of solute upon mass of solution into 100. This tells us how many grams of solute is present in 100 grams of solvent. Concentration of heterogeneous mixtures such as milk, water, and spices mixtures can be expressed by this method. The example is, if 10 gram of salt is dissolved in 90 gram of water, calculate the mass by mass percentage of solution formed. Mass of water, 90 gram of mass of salt is equal to 10 gram. Total mass of solution, mass of water plus mass of salt. Now both equate to become 100 gram. Mass by mass percentage, mass of solute upon mass of solution, 10 upon 100 into 100, that is 10% per mm. This is the nutritional information given on the food packets. You can see we have total energy, total fat, protein, cholesterol, carbohydrate, added sugar, sodium, potassium, calcium, phosphorus, iron, riboflavin, niacin, and thiamine. Now, mass by volume percentage 5 m upon V R W upon V. Measuring the volume of liquids easy to this method is used in medicine and laboratories. It tells us how many grams of solute is present in 100 milliliters of solution. Mass of volume percentage, mass upon solute upon volume upon volume of solution into 100. If 5 gram of glucose is dissolved in 100 ml of water, then find concentration in mass by volume percentage. Mass of solute is 5 gram, volume of solution is 100 ml. The mass of solute upon mass of solution into 100. 5 upon 100 into 100, that's a 5 percentage m upon v. Now volume by volume percentage v upon v. When two miscible liquids are mixed, then this method is used. Such perfumes, cosmetics, and vinegars. The volume by volume percentage tell us how many milliliters of solute is present in 100 milliliters of solution. Volume by volume percentage, volume upon solute, volume of solute upon volume of solution into 100. Example, if 1 ml of pesticide is mixed with sufficient amount of water to make 100 ml of pesticide sprays, calculate its volume by volume percentage. Total volume of solution 100 ml. Volume by volume percentage, volume of solute upon volume of solution into 100 is equal to 1 upon 100 into 100. That is 1% of V upon V. We have some example of ingredients: water, salt, acetic acid 4%. Like in vinegar, we can see that in your labels. Note: commonly used unit in industries is weight percentage. Percentage W upon W as weight and mass are generally interchangeable. Both are numerically equal. Saline drip in hospitals contains 0.9 gram of salt in 100 ml of a solution. It can replace lost fluids in the body. 0.9% m upon V. Now solubility. The maximum amount of solute that dissolve in a fixed quantity of solvent 100 ml or 100 gram is called solubility at a given temperature. A solution that cannot dissolve any more solute at that temperature is called saturated solution. Solubility of solute generally increases with temperature. Solubility of gases decreases with increase in temperature. Each substance has different solubility. A graph for solubility versus temperature is called solubility curve. This is the graph, temperature and solubility per gram 100 gram of water. The solubility of compound A in water at 20 degrees Celsius is less than solubility at 60 degrees Celsius. The lower the temperature, the lesser the solubility is. Solubility of compound B at 20 degrees Celsius is less than its solubility at 60 degrees Celsius. The solubility of compound B increases more than solubility of compound A with increase in temperature. Methods of separation of homogeneous mixture. Crystal. A crystal is a solid that is made up of particles arranged in a regular geometric pattern. Suppose we have a saturated solution of compound A at 60 degrees Celsius prepared by dissolving 287 gram of compound A in 100 gram of water. When we gradually cool this solution to 40 degrees Celsius, then pure solute separate out as pure crystals because 241 gram of solute can be dissolved in 100 gram of water at 40 degrees Celsius. In everyday life, we have seen crystals of sugar, salt, mystery, snowflakes are also example of crystal. Even frost formation on window is also crystal which is formed naturally in winters. Crystallization. In laboratory, the process by which crystals are formed from saturated solutions are called crystallization. This process can be used to separate two solids and purification of solids.